Hello there, my name is Peter Bossaerts. I am professor in the Faculty of Economics at the University of Cambridge, and I study decision making under uncertainty and complexity. In that I go beyond tradition in economics. The tradition in economics is to focus on choice, on behavior, and try to model choice using utility functions. That is, finding the right utility that summarizes how people are choosing. How do I go beyond that? Well, I try to find the neurobiological mechanics behind choice. That is, the neural processes in our brain and in our body, central nervous system, that explain these choices. The advantage of that will be that we'll be able to discover the constraints on choices, and as a result explain the many cognitive biases that we have in terms of first principles. It's a bit like what happened in cognitive neuroscience 20 years ago, when by the study of neurobiological mechanics people were able to explain cognitive biases, visual biases such as the Necker-Cube bias. So we're trying to explain, to apply the same type of procedure to choice. So as a result, people call me a neuroeconomist. The neuroscientists would refer to that as decision neuroscience. The mathematics behind these neural processes has formed, in fact, the foundation of artificial intelligence as we know it. It's the same principles that are used for large language models like ChatGPT. When you ask ChatGPT which country has the best beer in the world, and it answers Belgium, that then reflects the consensus on the internet about it. Where the idea of utility maximization, that is the core idea of economics, breaks down is when a value requires you to compute or to solve a complex problem, a combinatorial complex problem. I'll give you examples. For instance, you have to determine how to go from A to B in a congested city. Or you have to decide how to allocate your budget between lumpy items such as a trip to Spain, a car, maybe a house, things that are indivisible. These are very hard computationally. They're what the computer scientists call NP hard. And it's here that actually I get into computer science. So part of my work is actually computer science based on a model of human decision making based on Turing machines. As a result, my work is somewhere between economics, neuroscience, and computer science. So the neuroscientists would actually refer to that as computational neuroscience. Lastly, let me say a few things about the methods. I also deviate from mainstream economics in that I tend not to study the real world, the world out there as we observe it. I marry theory with controlled experiments where human subjects, and sometimes even animals, so it's like monkeys, where human subjects do certain tasks that allow us to infer what's happening in their brain, what's happening, how they actually solve the problems. It's not that I don't think the real world is not interesting. It's just because as the theory stands right now, with few exceptions, we're just not advanced enough in order to explain what happens in the real world because there are too many confounding factors. So in that sense, you could actually call me a standard natural scientist. Thank you.